Hello. So the second video we've got this week on functions is to do with inverse functions. Now this is a GCSE skill. Some of you may have encountered it at GCSE. It just depends on where you got up to when you were working through the GCSE at school. So we're going to talk it through from the beginning. We're going to have a look at what makes an inverse function, and then we're going to have a look at how to derive an inverse function when you're given the original function. So here, a typical question. The function f of x is root x minus 2, where x is a member of the set of real numbers and x is greater than or equal to 2. Remember, we're now looking at this part of the function and understanding that this is the domain. So this is instructing us that this function only exists for certain x values, and those x values are real numbers and they're also greater than or equal to 2. Yeah, not bad. So we're going to use that information to work out the rest. So if we look at part A, we're going to state the range of f of x. Now, if we were to plot the graph of square root of x minus 2, which is what we do, whenever we're trying to find a domain or a range and we're unsure about this, we can plot the graph and we can have a look. Well, not plot the graph, sketch the graph. So if we have a look at the graph of square root of x minus 2, it's like this. That's what that looks like. Okay, so that's the graph of y equals f of x. This point here is the coordinate 2, 0, and it doesn't have any y-intercept. Okay, how do I know that that's the graph? Well, this is a graph of the square root of x, which we can plot quite easily, and then it's been shifted, translated to the right by 2. So this is what the graph looks like. And if I've got to state what the range is, remember the range is a list of all of the y values that this graph can possibly take. Now, if you look at this graph, it only exists from the x-axis upwards. There are no negative y values at all. But anything from y equals 0, which is the x-axis, and up, could be part of this function. So the range is a simple. So we've got f of x is greater than or equal to 0. Now, why is it greater than or equal to 0? Well, we look at the domain for this. X can be greater than or equal to 2. If x is equal to 2, then 2 minus 2 is 0, and the square root of 0 is 0. So y, f of x, can actually be 0. So then we get into the meat of the question. We're going to find the function f to the minus 1 of x, and that's what this means. Is the f to the minus 1 of x is the inverse function. We need to state the domain and the range of this inverse function. So to find the inverse function, we do a little bit of algebraic manipulation, and we say let y equal the square root of x minus 2, our function f of x, okay, but we're just going to make it equal to y. And then what we do is we rearrange this so that we've got it in terms of x. So the first thing we would do is undo the square root, so we would have y squared equals x minus 2. Okay, remember, what we're trying to do is just rearrange this to get x equals. So then we can say y squared plus 2 equals x. And what we do next is a little bit, not iffy, but it feels like we're fudging it a little bit, because what we do is we just say we swap the y's and x's around. And so once we've actually got x equals something, all we've got to do is say x squared plus 2 equals our y. And that means, and for the final line, our inverse function, f to the minus 1 of x, is x squared plus 2. So just to repeat that, let y equal the function that you're working with, rearrange that function to make it x equals, swap your x's and y's around, and then write down f to the minus 1 or g to the minus 1 or what have you. So now we're asked to state the domain and the range for this function. So how do we go about doing that? Well, there's a simple rule to remember here, and we'll look at why this rule works in a second when we do part C. But if we were to state the domain of this function, the domain of the inverse function is equal to the range of the function. Okay, so what I can do is write that slightly differently to make it even clearer. So the domain of f to the minus 1 of x equals the range of f of x. So the domain is going to be where x is greater than or equal to 0, because it's the range of the function. We're just taking that and making it exact. Now remember, when we describe domain, we're talking about x values. When we're talking about range, we're talking about f of x values. So the range of the inverse function, f to the minus 1 of x, is equal to the domain of f of x. Okay, so we've swapped those around. And all we've got to do to find the range of f to the minus 1 of x is look back at the domain. We were given the domain in the question. And it's enough to say that f to the minus 1 of x is going to be greater than or equal to 2. Okay, so our domain previously was x is greater than or equal to 2. That's an x coordinate. Range is a y coordinate. So f to the minus 1 of x, our y coordinate, is greater than or equal to 2. And that's a simple thing, right? But you do have to remember it. The domain of the inverse is the range of the function, and vice versa. So in part C, we're being asked to sketch f of x and f to the minus 1 of x and the line y equals x. So I've put the line y equals x in here already. There's our x, there's our y. Remember our sketch of f of x looked like this, where we had 2, 0. And if we look at our function here, x squared plus 2, we know that that goes through the y-axis at 2, and we know that it's a quadratic. Now we only sketch that quadratic to the right of the y-axis because the domain of the inverse function, the x values that we're interested in for the inverse function, we have defined as x has to be greater than or equal to 0. So this function here, the inverse function, only exists for values of x greater than or equal to 0. And we know that this goes through the y-axis, 0, 2. Now the thing that we're being asked to spot here, by plotting this graph of y equals x as well, is that if you take the original function y equals f of x, and you reflect it in the line y equals x, and you get the inverse function. Notice the 2, 0 intercept has become a 0, 2 intercept. The shape of the graph is the same. This y equals x is the mirror line. And that's a bit, it is an explanation of why the domain of the function becomes the range of the inverse function. Okay, it's like x becomes y becomes x, because it's being reflected in the line y equals x. Let's have a look at a second question. We've got a different function here. F of x is defined by x squared minus 3. The domain, x is a real number, and x is greater than or equal to 0. Part A, and ignore this sketch for now, it's going to help us later, we're being asked to find f to the minus 1 of x. So our standard procedure for this, and this is standard procedure, is we'll let y equal the function x squared minus 3. The domain isn't relevant for this part. We're going to rearrange this to make it x equals. So we'll have y plus 3 equals x squared. X is equal to the square root of y plus 3. And that means we're going to swap our x's and y's. So therefore, our f to the minus 1 of x is the square root of x plus 3. Now we're not asked to state the domain, we're not asked to state the range, but we will anyway. So the range of this function is the domain of the original function. So f to the minus 1 of x is going to be greater than or equal to 0. And the domain of this function is the range of the original function. Not f, just x here. And I can see from this, if we think about x squared minus 3, it's a quadratic that's been moved down by 3. So the y values are going to be anything greater than or equal to minus 3. So for part B, it says sketch y equals f to the minus 1 of x. And that's what this sketch is right here. Okay, we've got square root of x plus 3, which is the square root of x graph again. But this time it's being translated to the left by 3. And see, we've got this minus 3, 0. Now that fits with our domain that we predicted. X is greater than or equal to minus 3, so anything to the right of minus 3 is included, nothing to the left. And the range of this graph is going to be greater than or equal to 0. You can see here the graph only exists above the x-axis, so the y values are all positive, i.e. greater than or equal to 0. So that's our sketch, okay, and we've got our intercepts marked in as we need to do. So now we're being asked to solve the equation f of x equals f to the minus 1 of x. Now, if we do this, and we just jump in with both feet and say, okay, f of x equals f to, not f dash x, s to f to the minus 1 of x, then we would end up trying to solve the equation x squared minus 3 equals square root of x plus 3, which would be x squared minus 3 squared is x plus 3, which comes out horrible. It's what? X to the 4 minus, pardon me, minus 6x squared plus 9, so typically the x plus 9 to go 3 plus 6 equals 0. So just skipping ahead, we'd be trying to solve this awful looking equation. And that's not easy to do. But there's a quick way, okay? If we're asked to solve f of x equals f to the minus 1 of x, we use this property that the graph is reflected in the line y equals x. So here is our f to the minus 1 of x. All right? I'm also going to sketch in here our f of x, which would look like this. So it comes from minus 3 down here. And let's see if I can get this part right. It goes like that. It's a terrible quadratic, but you get the idea, hopefully. So there it is, okay? Now, where do the two lines intersect each other? Where do y equals fx and y equals f to the minus 1 of x, where do they intersect? Right here. They intersect on the mirror line. And that's always going to be the case. If the two inverse functions do intersect, and they don't always intersect, but if they do, they will always intersect on the mirror line, y equals x. Now, what this means for us is we can solve the equation f of x is equal to x. Okay, y equals f of x intersects with the graph of y equals x, which means that just x squared minus 3 equals x, which means x squared minus x minus 3 equals 0. And using the equation solver on our calculators, from memory, let's see if I've got this right. From memory, we've got 1 plus or minus root 13 over 2 are our two roots of this. Now we can see that our intercept here is a positive x value, so we can say therefore x is 1 plus root 13 over 2, because 1 minus root 13 over 2 negative. So that's me just getting my calculator out to verify that I've solved this correctly. Yes, brilliant. So that's our intercept, okay? So if you're ever asked to solve the equation f of x equals f to the minus 1 of x, don't just automatically make the two equations equal to each other and try to solve. You may end up in lots of trouble. Just remember that if they do intersect, then they will intersect on the line y equals x, and so therefore we can solve f of x equals x. That's it for inverse functions. So have a quick questions. Post any questions that you have in the chat, or indeed ask me next time you see me. And next time we'll look at composite functions. See you later.